Okay, welcome everyone to this continuation of machine learning in mathematics. Keep in mind, not the mathematics of machine learning, which is kind of fun in self-study, but how machine learning is used in mathematics. My very biased list, actually not my biased list, I asked ChatGPT to generate me a list of topics. We're in 2025, so I'm recording this video in 2025. If you watch this video in the too far future, be careful because things are moving so fast. Probably it's very outdated. Probably it's actually already very outdated as I'm recording it. But I still go for it. And today I will go for translation. So essentially the idea of translation, just in a mathematical sense, or not really in a mathematical sense, in mathematics, where translation is much more difficult than, well, let's say standard translation. Or maybe not much more difficult, but at least not as well studied as standard translation via machines. But anyway, my story starts with word embeddings. So if you are from the old generation, like me, then the real translation that you have seen when you were younger, essentially you had a dictionary. You had a dictionary, you looked up a word, whatever, blah. And blah translated to language, from language X to language Y would be bloop, something like that. And this is like very well studied in computer science. And machine learning, and it's part of mathematics anyway. They're called word embeddings. So essentially there's a standard way to represent, well, a word as a number, or as a vector in this case. So you embed it in a certain high dimensional space, and these are called word embeddings. So that's kind of a standard way of doing it. Not going to explain it. But you can easily assign, whatever, a value in R2 in this case, two words, whatever, R2, like party or crisis, money, day, whatever. They live somewhere in this space. And you can do that in an arbitrary language, and usually kind of the translation of the word ends up close by, whatever, crisis, and here it's the German one, would be Krise. Very good. So it kind of works out quite well. Sometimes there's some ambiguity, sometimes their words will mean different things or whatever, but it works pretty well, and this is essentially the dictionary way of translation. And that was known just to do it with AI. I'm not quite sure whether you can call this AI already, but anyway, you can do it with a machine, and essentially it's just assign to it a number, and closed numbers will be the translation essentially. So that's kind of a very old way of doing it. Dictionaries are around for, I have no idea, as long as dictionaries, as long as languages around. Probably not quite, languages around for a longer time, but dictionaries are around for some time. Maybe not as books, because book printing is actually pretty new if you compare it, well, to the greater scheme of human history, but dictionaries have been around for some time, and this is just, it's kind of very amenable to kind of the machine learning types, the mathematics. It's just translated into numbers. More difficult is translation. So it's really translation. So translation of a sentence, not translation of a word. Translation of a word is pretty easy, that we just said. But really translation of a sentence. So I asked ChatGPT to translate, I would like to translate the sentence into its 10 favorite languages, which are apparently Spanish, French, German, Italian, Portuguese, Dutch, Russian, simplified Chinese, Arabic, and Japanese. So apparently that's ChatGPT's favorite 10 languages. And it works really well, actually. And if you are from a younger generation, that might not surprise you, because it has been around now. Translation with AI has been around for a while. But it's actually fairly new in the greater scheme of things, because it essentially relies, the modern versions of it rely on a transformer, which is a certain type of neural network that is designed to understand meaning. So in 2025, when I'm recording this video, translation is really a pretty easy task. Translation to more, well, at least translation something like from English to French is pretty easy. From English to Mandarin will be a bit more difficult, because they kind of have a very different grammar and a very different way of writing things. But it's still pretty straightforward. And kind of this breakthrough, I would like to say, came from those transformers, which were essentially built to understand the meaning of a sentence, right? So in order to do a really good job in translation, you really want to understand the meaning of the sentence. Otherwise, you will end up with something the older generation, like me, are still very familiar with. So if you start the old ways of how a machine translated the sentence was this word-by-word type of translation. So here's a fun picture. So the French one is original, and the English and the German one are translated word by word. And, well, I guess the meaning is clear, but it sounds quite funny. Pull the door. This toilet has use for all. And the German one is even funnier. So if you can't read German, I feel sorry for you right now, because the German one is really just, it's really fantastic. Fantastic. Anyway, so those word by word translations, we can try that here as well. So, whatever. Can you translate... What I use? I would like to translate this sentence into your 10 favorite languages. And don't worry that I can't spell, it doesn't matter. So let's see what it does. Okay, so this is what I did before. Yeah, whatever. German, Spanish, French. Is it the same list? Italian? No, not quite. Not quite. But kind of Spanish seems to be its favorite. And now the same, but the old way of translating it, word by word. So let's see what comes out. Now it gives me a list. Fine. Whoop. For me, the German one is the easiest one. Ich möchte, used together, möchte, meaning would like. To implied to möchte übersetzen diesen Satz. Ich möchte diesen Satz übersetzen. No. No! I really mean word by word. You shouldn't do a good job, right? I'm trying to convince you to not do a good job. So please don't do a good job. Please, no good translation. Maybe I shouldn't write this, but anyway, let's try. Oh, you're still generating. Oh god, yeah, fine. You're still generating. Okay. Got it. As literal as possible. Exactly, that's what I want. Thank you so much. Sometimes ChatGPT is much smarter than I would like it to be. Because if you really... So here I would like to translate it and it just gives me the list. Perfect. But I want a word by word and it just does it word by word. It just lists the words. Anyway. Which is what I said, I guess. So here we are. Well, let's do German. It's easiest for me. Isn't that the same? Übersetzen diesen Satz? Yeah, not really. Well, you can try that yourself, right? Slightly is different. It usually gets much funnier if you just keep this in mind. So the old way of translating, which I'm still pretty used to, so like 10 years ago, this is how a machine translated sentences. It's kind of pretty bad, essentially. And the transformer was like the breakthrough. Nowadays, it's just so smooth. It's just unbelievable how good it is. So if you ever need to translate something that is not that difficult. And translation could mean you translate something you want to do into code. Works really well with those programming languages. But something that has been actually quite tricky and still is quite tricky is to, well, translate a proof, a human written proof, into a formal verified proof. So proof assistants are supposed to do that job for you. Well, they're supposed to help you with this. So proof assistants were developed quite a while ago. What is the oldest one? What is the oldest proof assistants? Maybe it's Coq. Let's see. So Coq is one of them. Yeah, it's quite old. They're probably older ones, but there's a whole list of these guys on proof assistants, and we'll zoom into Lean in a second. And they're essentially designed to formalize proof. So if you think about the Principia Mathematica, the big book a long time ago, which was trying to formalize mathematics, if you want, it's quite difficult to do that really in formal language. I'll give you an example in a second. So it's quite difficult to do that in formal language, and yeah, so these things are supposed to help you with it, and it's still terribly annoying to translate a human written proof into a machine into machine language, something the machine can understand. And you should really think about whatever the machine can understand, or whatever those proof assistants can understand, is like a new language. Right? You have human language and you have computer language if you want. So you should be able to use a transformer to really just translate between the two. Right? Transformers are built to translate. The only real difficulty here in the mass proof is that like the meaning is like really crucial. And apparently the transformers are not quite good enough to do it, or at least recently people tried to do it. But the standard transformers that you will find shouldn't be able to do it and will do mistakes. So the people looked at this, and the best I found is, well, let's say for Lean. Lean is a very popular one, a pretty new one. Where is Lean? Where's Lean? A pretty popular proof assistant. Very nice actually, but I think very new. Yeah, 12 years ago. It's pretty new for a proof assistant. And yeah, so people were just using Lean, and there's a transformer-based, they trained a transformer-based neural network, so a large language model, essentially for auto-formalization, and they were able to get 75% of the proofs formalized correctly, roughly. So you give it essentially a screenshot, not quite, then you need to give it a text, but anyway, a screenshot of an undergraduate level proof. That's what they were able to do, and with 75% it will be able to formalize the proof so that you can then run it in Lean, which is pretty good because that's a proof verification, right? So if you take a screenshot of a proof and ask ChatGPT or whatever kind of large language model you want whether this is a true proof, there's still a probability involved, so it's not really formal verification. But if you do it like this and you translate it into a formal language, and then let the proof checker check the formal language, then it's actually proof verification. So that would be pretty good, right? So take a screenshot of your proof, or you whatever, upload your own paper, and it will tell you, well, that's a mistake on page 5, something like that. So that's kind of the big idea. And right now, yeah, we are not doing all that well. 75% an undergrad level proof. So here, down here is one of these don't look pictures. So don't look. You can look at the paper. It's linked in the description. But essentially, they formalize the idea that the power set is closed under intersection, which is like an almost trivial proof. But the whole point is to go from the kind of human proof to the computer proof is usually not easy, and you can just do it essentially, and then it's computer verified automatically, which is kind of cool, right? So you can essentially, that's my hope at least, you can essentially hopefully at one point just upload your paper and it will tell you whether you have messed up or not, or you take a picture of your proof, you just write it on paper and it will tell you whether it has been successful or kind of whether it's true or not. But right now we are still lacking a little bit. It's kind of really difficult to translate because kind of the meaning is so crucial. As soon as you swap a little symbol, the whole proof is messed up, which you can then try to repair because most of these proof assistants actually have some automatized proof theorem proving built in, so you can somehow try to correct that. So the 75% is like the literal translation, and then you can still do better. So it's actually maybe not in a bad state, but as it is of right now, I can't just upload my paper, and probably most of them will have mistakes anyway. So I remember an old story when I was young, and I read my first paper, and there was a sign mistake in that paper, and I got completely obsessed with this sign mistake. Tried to fix it, and it was very. This wasn't a big mistake, right? But I was very inexperienced, and it took me a long time to fix it. And then I went on, and there was another sign mistake a few lines later, and they consolidated it out, so the theorem in the end was true anyway. So there you go. Just ignore sign mistakes in papers. Almost all papers have some mistake in it, and it would be so good to just upload them and ask, is this correct or not? But we are not there yet. Hopefully, eventually at one point we will, because then we can replace all mathematicians, which is our goal anyway. Anyway, I hope you enjoyed this video, and I also hope to see you next time.